This is what you call an easy 6 marker. This question came in paper 4, variant 2 of IGCSE math earlier this year, and all they're asking for is the nth term of each sequence A, B, and C. So let's begin solving them one by one. So here's my recipe. Always write the terms vertically against their term number. So for example, 1, 2, 3, 4, 5, and here we have 5, 12, 31. I'm talking about sequence A. 31, 68, 129. It helps you spot the pattern instantly. So in sequence A, terms are 5, 12, 31, 68, 129, like we just jotted them down. So we could try doing a few things to them. Maybe square them, then cube them, try multiplication or something. So when I square them, I get 1, 4, 9, 16, 25. I'm squaring these terms, okay? So is there a relationship between the outcome? Let's call these outcome or the results and this. So 1, 5, 4, 12, 9, 31, not really, right? Now, if I cube them, I get 1, 8, 27, 4 cubed is 64, 5 cubed is 125. Now, is there a sequence? 1 and 5, 8 and 12, 27, 31? Yeah, I can definitely see that they're all short by +4, right? So I can easily spot that this is what? This is actually n cubed. The term is cubed plus added by a constant 4, okay? So the nth term is simply n cubed plus 4. Now, in sequence B, let me just erase it, right? So that we have more white space to work on. Give me a bit. Okay. Now, in sequence B, numerators are 10, 9, 8, 7, 6. They are constantly decreasing, right, by a unit. And the denominators are 3, 4, 5, 6, 7, and they are constantly increasing by a unit, constantly. So this is a classical case of an arithmetic progression. Uh, in arithmetic progression, we have the term n denoted by. So if you want to earn full marks, you must make a note of this. It is a plus n minus 1 times d, where a is the first term and d is the common difference. Okay. Now, for the numerators, right now we are discussing the numerators. The first term is 10 plus n minus 1 times d. The common difference is minus 1, right? So common difference is calculated by term n plus 1 minus term n. So this is 9 minus 10 or 8 minus 9. So it is minus 1, right? So this becomes, so term n becomes 10 plus 1 minus n. So this is 9 minus n. So the numerator becomes this. Now, if I work on the denominator, now let's do the denominators, okay? Let me use another color. So this is term n is equal to, denominator starts with 3. So a is 3 plus n minus 1 times d. Now the difference is 4 minus 3 or 5 minus 4 or 6 minus 5. All of them are 1. So this becomes 3 plus n minus 1 or 2 plus n. Okay. So this is the answer for sequence B. Now, sequence C, in this one, each term is getting multiplied by 2, right? Now, this is a classical case of a geometric progression where each subsequent term has a common multiple, right? And how do you find this ratio? You can do term, let me just erase the previous one so that you're not getting confused between arithmetic progressions and the geometric progressions. So in this one, in this geometric progression, the common ratio is denoted by term n plus 1 over term n. So we can see 64 upon 32 is same as 32 upon 16, is same as 16 upon 8, is same as 8 upon 4, which is nothing but simply 1. So r is which is nothing but simply 2. So r is equal to 2. Now, in a geometric progression, the term n is denoted by a times r, which is the common ratio raised to the power n minus 1. So a is what? A in our case is 4 into r, which is 2. And here we have n minus 1 for term n. However, we can further simplify it by writing this 4 down as 2 and then distributing the power. So this becomes 2n upon 2. So this becomes what? This 2 cancels this. So this becomes 2 into 2 power n. So this is simply 2 to the power n plus 1. So we can write this as 2n plus 1, right? So the final tip is if you can recognize whether something is cubic, which was this one, n cube plus 4, or arithmetic, which was sequence B, or geometric progression, these questions are guaranteed marks. Don't skip them in practice, they're easy wins. So what you can do is you can share it with your pals and you can learn these. You can save this video and learn this for any of your number pattern questions that comes your way. All right, I'll see you with the next question.